This is geometry lesson 7.1. We're going to start exploring triangles and what makes them congruent, how much information is needed to prove that two triangles are congruent. Remember, congruent means the same size. And today we're just going to start with the basics, as this is the first lesson in chapter 7. So, can we draw triangles that are congruent based on different types of given information? So, the big idea says some combinations of measures of sides and angles are enough to determine all of the other measures of the sides and the angles of the triangle. For instance, if you have two of the angles of the triangle, we know you can find the third by subtracting those from 180. Can we do similar things with the sides or combinations of sides and angles? So, in the book, it starts by exploring why triangles are used very often in what's called these trusses when you're building the roof specifically on a house. And it's not just for the design of it in terms of how it looks, they are very strong compared to other shapes that you could possibly structure these as. So they're very rigid and they can hold up to more weight than other shapes. So triangles are very strong like that. Um, and then it kind of poses some questions here. So it says, I'll summarize here. Suppose you were the builder and all of these trusses come in. You can see it's basically just pieces of wood that are formed together uh, in the shape of a triangle. So suppose you have all of these and you discover you're one short, and you need to call the supplier and you need to order one more. Now you can see these are all in a row, they're all identical. These would all be congruent triangles. Reminder, that's what congruent means, same size. So all the angles are the same, all the sides are the same. So you have to call the lumber yard and you need to order one more. What information would you have to give to the supplier, to the lumber yard, to ensure that that truss that you get matches all of the ones that you have? If you provide the lengths of the three sides and the measures of the three angles, would you get the same one if that's all you gave him? You said, here are my three angles and here are my three side lengths. Is that enough information that you're going to get the identical triangle? Or would you have to say potentially which angles are between which sides? So we're going to kind of explore how much information and what information is necessary. So whenever a set of conditions is enough so that all figures created will be congruent, we will call that a sufficient condition. Okay, we're going to use that word a lot, and you'll see that in your homework. So let's say if I just gave you one angle, is that a sufficient condition? No, we don't know what the other two angles are. We don't know what the side lengths are. But if I do tell you the three side lengths, can you create a congruent triangle based on that information? The answer is yes. We're going to jump into that here. That would be a sufficient condition for determining the figure. All right, so there's a couple different combinations of sides and angles that we're going to study a lot. We're going to talk about proving different things with them, um, discovering them in pictures, so on and so forth. But today we're just going to talk about if you're given this information, for instance, three side lengths, is that enough information for you? Is that a sufficient condition for you to draw a congruent triangle? So the first condition we're going to look at is called the side condition, and we will abbreviate all of these. So it's just sides and angles, so SSS for side. So given the lengths of three sides of a triangle, a sufficient condition is met. So as I take a look at this picture, these are two congruent triangles. I have not given the exact lengths here, but this one side here that I would name AC is congruent to side PR because they both have one slash. This one with two slashes, CB, is congruent to QR with the two slashes, and the third side with the three slashes would match as well. So specific to the drawing triangles, what we're talking about here is if you were given these lengths, so let's say this length was 10, these look to be equilateral triangles, but let's just say they were really close, like 11 and 12. They do appear to all be the same length, but let's just say I tell you to draw a triangle with these side lengths, And you grab a ruler, assuming that these actually were physically these lengths, and you try to construct a triangle using these side lengths. When you finally draw three lines that intersect at their endpoints and they all connect, you would in fact have a matching triangle to this. There's no other way to recreate this triangle to have these three side lengths except for what's given to you right here. So having three side lengths is a sufficient condition for creating a congruent triangle. There's no other way that you could create this with those three side lengths that wouldn't match the original. Now, let's look at a condition where this is not met, and one we've kind of talked about already earlier in the book. Angle, 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 which we would obviously abbreviate with AAA. If you have two triangles with the same angles, we talked about size transformations in previous chapters and how some things were preserved, like angle measure. So I could increase the size of this shape by, say, 3 or 1.5 or whatever. And distance is not preserved. The side lengths change, obviously, much bigger triangle. But those angles are still the same because remember, every triangle has three angles that add up to 180. It doesn't matter how big the side lengths are, those angles still add up to 180. So by increasing the size of the side lengths, I am not affecting angle measure. The angles are still the same. So because of that, given the three angles of a triangle, if I told you that this was, let's say, 80, this was 70, and I gave you this one, whatever, and I said, draw a triangle that's congruent to that without you actually seeing it, just giving you the angle lengths, you couldn't do it. You would be drawing something that could be bigger, it could be smaller. There's all different options of what could happen. You could match all three angle measures, but that doesn't mean your sides are going to match mine. Whereas up here, if I create a triangle that has these three side lengths and they match, even if I didn't give you what these angles were, the new one that you draw is going to have matching angles. There's only one way to create this triangle. So having three side lengths is enough to create a congruent triangle. Having three angles is not. Okay, the side lengths could be totally different sizes. Now they would be multiples of this, right? It would be all of the sides times 3, all of the sides times 0.5 if it was getting smaller. Okay, but the angle measures could be the same, and congruent means all the sides are the same, all the angles are the same. So it's not met. Just because you have three equal angles does not mean you have a congruent shape. Okay, because you don't necessarily have three equal sides. Okay, a couple more cases on the back. These are all ones that do work. Okay, so first of all, we need to know what this word included means. So included angles, we'll also talk about included sides. So two sides of a triangle form part of an angle, right? We've got these two sides right here. Where they meet is the angle. Angle A is where side CA and side BA meet. The angle that is said to be included by the sides, so the angle included by these two sides is the angle that's created where they intersect. That's called your included angle. So the next one we're going to look at is side angle side, or SAS. So if you are given two side lengths of a triangle, so you actually know that this is, say, 7 and this is 6, and you know that this angle right here is, say, 60 degrees. Now notice it has to be the one that's between those two given sides. Okay, has to be. But if that's true, I can draw a congruent triangle to that. So it has to be two sides given to you and the angle that is included, which basically means between. This is a sufficient condition. Let's talk about why. Let's say I drew a side length with a ruler and it was measured out to 7. I just drew a line and made sure, measuring with a ruler, that it was 7. And then with a protractor on this included part, I'll do it down here. It doesn't have to necessarily be up here. I measured out exactly 60 degrees. All right, I got this line here, and it's exactly 60 degrees. And then I extend this line to exactly 6. Okay, I can't extend this any farther. I can't extend this any farther. It has to maintain that 7 and that 6. When I go to connect these two, there is no option. These angles that are out here are automatically going to match these two angles that I've created right here, because this side and this side with this angle have to be connected right there. There's no other way to connect them. Okay, so having a side angle side triangle is enough information to recreate and create a congruent triangle. And then the last two sufficient condition combinations are down here at the bottom. We have ASA, angle side angle. Okay, so you have two angles and then also the included side. So not just any two angles and one random side. It has to be two angles with the one side length given between it. The reason that is because, like, let's say that this was 5 and I just use a ruler. I draw a line at 5, and then using a protractor, I match this angle and I match this angle. Well, there's no way for me to come up with multiple combinations of triangles here. These two sides are going to extend until they meet. And so those two sides are going to match the two sides of the original. So angle side angle, again, has to be the included side. So between those two angles, that is a sufficient condition. And also angle angle side, AAS. So given two angles of a triangle and a non-included side, a sufficient condition is met. Okay, so if I match this angle, let's say this is 50 degrees. Let's say this one was 60 degrees. I know they look like they're matching, again, but for the sake of argument, and I had 6 right here. If I created this angle, right, and then I create this angle, and it matches, so I've created a 50-degree angle. I haven't extended that side fully, and I create a 60-degree angle, and then you're telling me that this other side has to be 6, so it goes out here somewhere, 6. Well, the only way for me to make this a triangle is for me to extend this until it hits that side, right? There's no other options here. Okay, so angle, angle, side also creates that for you. And just to jump back real quick to the original one, the side, side, side. If I was trying to recreate this one, you told me those 3 side lengths. If I draw my side of 10, right, and then let's say I drew my side of 12 this way, well, and I didn't have a matching angle, this side of 11 would come up short, and it wouldn't create a triangle. So if I could draw these 3 sides and actually get them to connect, I am going to have a congruent triangle to the original, and that's why side, side, side works. Okay, so we have angle, angle, side, angle, side, angle, side, angle, side, and side, side, side. Those are the sufficient conditions for creating a congruent triangle.